or cervical scale, which was developed in the year, I think, 1980 or 70 or something. If we are using the same scale in this time period also, and scale is still giving me the consistent results, means in that case we can say that the scale is reliable scale, or scale is following the stability component, right? So that way, this is the stability reliability. Talking about internal consistency, from the name itself, it is quite clear. Internal consistency means when whatever items we are keeping in the scale, whatever items we are keeping on a scale, if the items are related to each other, in that case, we can say that the items or that the scale is internally consistent. So you need to check the correlation among the items, and that way we can say that the scale is internally consistent. So that way, broadly, these are the two divisions of reliability. Now, if I talk about methods of reliability, so there are four methods available. The first one is the test-retest reliability, then parallel form reliability, then split half reliability, and lastly, the internal consistency reliability. Using these four methods, we can check the reliability of the scale. Usually, the first two, that is test-retest and the parallel form reliability, these two we can keep inside the stability, right, or stability reliability. Now further are the split half and the internal consistency. So firstly, I'll talk about the test-retest reliability. So I think rather than reading the text, I'll explain you on with the help of the diagram which I have developed by my own. Using this diagram, we see that if I talk about test-retest reliability, so in test-retest reliability, you can see we are having a test. Test means a questionnaire or a scale or a instrument. One in the same thing, right? Test, questionnaire, instrument or scale. All are having the same meaning in the research, right? So in that case, we can say we are having any test, we want to administer that test on the people. So in that case, you can see if we are giving that test to a particular group of respondents, and same test we are repeating after a fair time interval on the same people, on the same group of people, and that way we are collecting the scores of both the conducts. And in those scores, if we are finding the coefficient of correlation, and if this coefficient of correlation value is greater than 0.7, in that case we can call that the scale is reliable according to test-retest reliability, means test and retest. So firstly, I am using test and I'm again testing the same test. So that means I'm conducting it twice. So same test we are circulating twice to the same group of people, but in the two conducts there would be a sufficient large time gap you need to maintain for both the conducts, and you need to collect their scores, and we can find the coefficient of correlation among these scores, and that way we can conclude that whether the scale is reliable or not as per the test-retest reliability. I hope it is clear.
Yes, ma'am.
Yeah. Talking about the next is parallel forms reliability. So parallel forms reliability, again, I have tried to explain it with the help of diagram. We can see when we are talking about parallel form reliability, here we are dividing the test into two parts. Say, for example, in my test, there are 50 questions. So might be possible first 25 I have put in the first part, next 25 I have put in the second part, or all the even question I have put in the first part and all the odd questions I have put in the second part. And that way I have given the first part to the group of respondents, and after a short time period I am giving the second part to the same group of respondents. So parallelly I am using the scale by dividing it into the two parts to the and giving it to the same group of people, and I am collecting these scores, and then I'm checking the coefficient of correlation among those scores, and that way if the score value, the coefficient of correlation value is greater than 0.7, so we can call the scale is reliable as per the parallel form reliability. I hope it is clear.
Yes, ma'am.
Yeah, thank you. Moving ahead, talking about split half. Split half reliability is Here, what we will do, rather than dividing the test, we will divide the respondents into two parts. Suppose I am having 100 respondents, I am keeping 50 respondents in first group, remaining 50 I am keeping in the next group, and I am giving the same test or same scale to both the groups, and I am administering that particular scale to on the same group, on the two groups at the same time. And that way I'm collecting their scores of group 1 and group 2, and I'm finding the correlation among those scores or between those scores of the both the groups. And if I'm finding the coefficient of correlation value greater than 0.7, that way I can say scale is reliable as per the split half reliability. Is it clear?
Yes, ma'am.
Now we are talking about the most important type of reliability or the method of reliability, that is the internal consistency reliability. Internal consistency reliability means it refers to the degree of homogeneity of items in an instrument or a scale. Means whatever questionnaire or instrument we are talking about, whatever items, item means questions, right? So whatever number of questions you are taking on a scale, they should be somewhere homogeneous in nature. So that way we are finding the homogeneity degree among those questions in a particular scale. So that means this particular method will tell you whether those items or those questions are internally consistent means internally they are correlated or not. If they are correlated, up to what extent they are correlated, whether the amount of correlation is good among those items or not, that we can check using the internal consistency reliability, right? So to make this thing a little easier for you, I tried to take one example here. Here I'm talking about a motivation. I think yesterday I have coined a term, construct. I think one of you have asked me at the end a question also on construct, right? So if I say motivation is a qualitative phenomena. We can only say means we cannot see or we cannot measure the motivation in any particular person, but we know there is a particular type of thing available which is called motivation, which is a drive through which drives us to do something good or better, right? So that is a thing which we want to measure, whether that motivation is positive in us, whether the motivation is negative in us. We need to check that. So we need to measure the motivation level in a person, and as we know there is no apparatus available to measure this particular motivation, so we can understand this is a qualitative phenomena. So what we can do, we can create or we can make certain number of questions which are leading or which are helping us to understand the motivation level of a person, right? So for example, you can see in the diagram, suppose we are having a motivation, which is your construct or latent variable. Latent variable means it is a variable which we cannot directly measure, right? So to measure it might be possible, we have taken the help of certain items or certain statements, certain questions, right? So might be possible we are having total 10 questions to measure the motivation of a person. So if these 10 questions are fairly correlated to each other, in that case we can say that these items are fairly correlated, and that way we can say that scale is internally consistent. Means the internal consistency reliability is followed by our scale. So this is the meaning of internal consistency reliability. I hope the meaning is clear.
Yes, ma'am.
Okay. Today I think people are very dull. Are you people getting me properly?
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
Okay, fine. Thank you. Moving ahead, talking about internal consistency. So usually, as maybe many of you have heard about Cronbach's alpha. So in SPSS or in other softwares, this facility is available. Using Cronbach's alpha, we can check the reliability of the scale. Cronbach alpha is very famous or very renowned kind of test, very popular kind of measure or test available. Using that, we can check the internal consistency of the scale, right? So it is given by American psychologist Mr. Lee Cronbach. So after his name, this particular measure is known as Cronbach's alpha. It is denoted by generally alpha, right? So but this particular measure helps us to measure the inter-item reliability or internal consistency among the items of a particular scale, right? So generally, up to what extent those indicators or those items are related to each other, this type of measurement we can do using the Cronbach's alpha. This Cronbach's alpha we can use for dichotomous scale variable also, and for the continuous items also we can use the Cronbach's alpha, right? Further, if I talk about the measurement of Cronbach's alpha, so manually the formula is available. There are two methods, variance method and the correlation method. Usually correlation method is more popular in comparison to the variance method. If we want to calculate manually, this formula we can use, but I think we do not need to do that now because this is the era of softwares. We are living in the technical world, so we do not need to pay this much efforts or put these much efforts to calculate the value of Cronbach's alpha. And in SPSS we are having a particular section available there we can use to calculate Cronbach's alpha, right? Further, now if you are getting the alpha value, now how you can interpret that particular value? So looking at the table here, I'm reading this table from the bottom side. From bottom to up I'll go, right? Here if I say alpha value is less than 0.5, means if you are calculating Cronbach's alpha for your data and your alpha value is coming as less than 0.5, in that case you can call it as unacceptable reliability. But if alpha is falling in between 0.5 to 0.6, you can call it as a poor reliability. In between 0.6 to 0.7, this is known as questionable reliability. Between 0.7 to 0.8, it is known as acceptable reliability. Between 0.8 to 0.9, it is good reliability. And if alpha figure is greater than 0.9, this is excellent reliability. And in that case, there is a problem. And this problem is known as the problem of multi-collinearity in the data. Because as I said, I think you people are knowing the concept of correlation, although we are discussing this concept in this particular FDP. Correlation is generally telling us how two variables are related to each other, right? So usually if the similarity is more among the two things, there would be the high level of correlation. I think it is quite simple concept to understand. So as we are calculating the Cronbach alpha is based on the concept of correlation. So that way, if two variables are related to each other, that means they might be possible little bit similar or they are more similar to each other. When alpha value is greater than 0.9, 0.9 means maximum it can be 1. But if your alpha value is greater than 0.9, which shows us that the two items are almost identical, they are almost similar, or the respondents are understanding that both the items or both the meaning of both the items is almost similar, right? So that way your alpha value is coming very high. And that way, this is a alarming situation for us. If we are getting the Cronbach alpha value is greater than 0.9, in that case, we need to read our scale, the items of our scale very carefully. We need to talk to the expert of the field. And if we are finding some of the items are very, very similar, in that case, we need to drop either of the question, either of the item from the scale to reduce the Cronbach alpha value. I hope people have got the understanding of multicollinearity and the interpretation of Cronbach.
Yes, ma'am.
Fine.
Hello, ma'am.
Yes.
Ma'am, this Cronbach alpha, this correlation, we can use it quantitative, both qualitative and quantitative data.
Sorry?
In this particular test, like Cronbach's alpha, we can use it for both qualitative as well as quantitative data.
No, it is only for quantitative data, sir.
Okay.
Whenever we are talking about a statistical test, I think a statistical test, yesterday itself I said, this is the biggest limitation. You need to code your data, qualitative data if you are using. Let's say, for example, Likert scale I'm using, right? So Likert scale is maybe possible. It can be the strongly agree, disagree, or strongly satisfied, or something like that. So these are the qualitative terms, but I need to code that data if I want to perform any statistical test, right? So in that case, you can code your data and you can perform the statistical test on that data. Is it okay?
Okay, ma'am.
Ma'am,
Yes.
ma'am, actually we are estimating the similarity using correlation coefficient also, ma'am.
Hmm.
But what is the difference between using correlation coefficient and this alpha factor? Is it one and same, like, or both are different?
So obviously there is a similarity, but both are not same exactly. If both are same exactly, in that case, rather than calculating the convex alpha, we can calculate the correlation, right? But it is based on the concept of correlation. As we know, correlation value lies from 0 to 1 or -1 to +1. But
Yes.
somewhere it is from 0 to 1, I can say, right? That means,
So what is the effectiveness of using this Cronbach's alpha for finding the similarity among the features?
as I said, sir, it is based on the concept of correlation, but it is not exactly a correlation figure. Only it is taking the concept that the value lies from 0 to 1. That is, in maybe in that way we can say, if I'm getting the alpha value is 0.7 or suppose 0.78, that means it is showing 78% reliability of the scale, right? So concept is of correlation, but somewhere I can say it is little different from the correlation. It is not exactly a correlation figure. As you can see, when I'm showing you the formula is just a minute. I think I need to, yeah. Formula is saying us alpha is equals to A divided by A minus 1 in brackets 1 minus A divided by A plus 2B. So where A is number of items or indicators and B is the sum of correlation of all the items. So in that case, we are using B as a sum of correlation here, right? So we are using correlation, but also with the correlation also we are using the number of items here to calculate the alpha value. So somewhere the role of number of items is also prominent when we are talking about alpha. Is it clear, sir?
Ma'am,
Yeah.
then can you suggest this Cronbach's alpha can be used for identifying the similarity features? In that case, can we use this and can we remove the similarly looking features? Can we remove it and we can select the distinct features?
I'm not getting your question.
No. Suppose if we have many features, among that, if we want to select a distinct feature, can we use this alpha coefficient to select what we require, distinct features?
Sir, I think I'm not getting your question. What do you mean by distinct feature? I think I haven't said any word like this.
No, as
I'm
you
not
said,
getting
we can find this. As you said, we can find the similarity. So after finding the similarity, we can remove which one reflecting the same information. We can remove, like you said, no.
Say for example, we are using in a particular scale, we have taken two questions. Suppose I am asking you a question. I like statistics. This is the first question. This is the first statement I have put in my questionnaire, right? Second is my statement I have given. I like to solve the problems related to statistics. Might be possible. And in that case, two items I have taken, and probably in these two items I am finding this convex alpha value or the quotient value is coming very high. Is it clear, sir? Suppose it is coming as 0.96.
Okay.
So that means the respondents are understanding the mean and they are taking both the items as almost similar or identical. So in that case, this would be the call of the researcher, which item he or she wants to remove from the scale. So that is the manual exercise software cannot do for us. We being a human being, we being a researcher, we need to consult with the expert expert of that particular field, and expert of that particular field, and we need to where I was. We need to consult with the expert of that particular field. We need to talk to the teachers, and that way we can come to the conclusion that which particular items we need to draw. As I think previously, maybe I think Shah sir said he said I'm an expert of my field, but still, sir, we alone cannot say this thing because this is our concept of perception, right? Maybe we are taking one thing from our point of view, of view, and other people are taking that particular thing from their point of view. So always there is a thing, there is a concept of perception. So always whatever scale we are developing, we always need to take the opinion of the other persons, those who are belonging to the that particular field. So I think you got my answer, sir, right? So if you want to drop a item distinctive or maybe similar, distinctive item obviously we will not drop, but the items which are very much similar, we are finding that correlation value is coming very high, right? So in that case, you need to contact to the expert of that particular field, that which item will be much suitable for us to drop from the scale. Is it fine, sir?
Okay, ma'am. Okay, ma'am. Got it. Thank you.
Okay, fine. So may I proceed?
Yes, ma'am. Yes, ma'am.
Okay. I think this is what we have already discussed about the multicollinearity. Now we are talking about how to perform convex alpha. So I think this is the process which we have to follow, and then using that we can apply the, or we can check the convex alpha or reliability of the scale. So this is what we will perform directly in the SPSS. Now, I think this is, I have already told you now. Yes, this is the most important part of this presentation. You can see methods of improving the reliability coefficient. So if suppose your Cronbach alpha value is coming the smaller figure, suppose it is coming less than 0.7. Usually when the Cronbach alpha is greater than 0.7, we can call it as the scale is reliable. But if scale is less coming, or the Cronbach alpha value is coming as less than 0.7, in that case, you need to think upon how you can improve, that particular Cronbach alpha. So there are three ways. First way is you need to check whether the missing values are available or not in your data set. Second, you need to diagnose that whether there is ambiguous or redundant items. That means this is the manual process. You need to read your questions properly, whether any of the question is having the dual meaning, whether there is some repetition is available in the items or not. That you need to check. And lastly, you need to see the item total correlation. This would be the output which we will get when we will apply the reliability or convex alpha process through the SPSS. So you need to diagnose the item total correlation there, and that way we can check what is the value of item total correlation is coming. So there is a threshold value. Generally, if item total correlation is less than 0.3, usually it is less than 0.3. In that case, we can drop those items. So for whatever item, the item total correlation value is coming less than 0.3, we will drop that item from the scale, right? And that way you can improve the reliability of your scale. So many a time it happens, people can take it as 0.2 also, but a standard figure is 0.3. If it is coming less than 0.3, in that case, you can delete that item. Or one more thing is there, normality we will discuss later on. One more case is there, you need to firstly check whether all the item total correlation are positive figures or not. If any of the item total correlation is negative, you need to immediately delete that item from your scale, and then you need to again apply Cronbach alpha and check whether the improvement is coming in the value of Cronbach alpha or not. And then further you will go to, or you will keeping to check the value of item total correlation until and unless for all the items the item total correlation is coming as 0.2 or 0.3. If you are achieving your results with 0.2 also, means Cronbach alpha is acceptable figure, so you can go with the 0.2 also. There is no problem in that case. Is it clear to all? Improvement is clear. Although we will perform all these things with the help of the data set I have given to you. So is it fine? May I proceed with the SPSS now?
Okay, ma'am.
Yeah. So just a minute, give me a second. I think I forgot to open SPSS today. Meanwhile, if you are having any queries, you can ask me. Meanwhile, it is opening.
Hello, ma'am.
Yes.
Will you share a data set sample or we will have our own?
I think I have already shared on WhatsApp.
I am not there on WhatsApp group, ma'am, so I could not
In
get
that case,
that.
you need to contact to the RFI members, ma'am. I think I'm not the admin there. They can share the link and they can add you. So if there, I think we need to check if someone is available. Is there anyone who is from RFI team? Yogaraj sir? Anyone is there from the RFI team? Sir, I think one of the participants is not there in the WhatsApp group. If you can share the link in the chat. Okay. Okay, so I think my screen is visible to everyone. I'm showing you the SPSS window. Is it visible?
Yes, ma'am.
Yes,
Yes, ma'am.
Okay. Fine. Now you can see. Firstly, I'll tell you how to import the data in SPSS. So I hope you all are ready with your SPSS window and you people have downloaded the dataset. May I start explaining you?
Yes, ma'am.
Yeah. So what you need to do, you need to go to the file menu. Then you can click on open and then you can select data. This is the one way. File, open and data. You got it? Everyone?
Yes, ma'am.
Okay, this is the one way. Second one is you can click on this open data and then directly it will show you the open data dialog box which you have found using this file menu, right? So one in the same thing, either you can click on this icon or you can click on this open and you can click on this data. This is the two ways. Third way is you can click on the import data and you can select which type of file you want to import in your SPSS, Excel, CSV, text, SAS, whatever it is, right? So these are the three ways through that you can import the data in SPSS, right? So for example, I'm clicking on this icon and this open data dialog box is coming. Now here, first section is showing you look in. Look in is what it is asking you to give the location of your file. So I hope you know where you people have downloaded your file. So you need to click on this drop down. You need to select the location of your file. Once you will click on the location, you can select the location of your file. Then you need to come to the files of type. Under files of type, I think I have given you the Excel sheet. So firstly, you need to set the extension of Excel. So once you will click on the Excel, all the Excel file in that particular location will be visible to you, right? So now what you need to do, firstly, you need to open this customer satisfaction towards restaurant file. Once you will click on this, you can click on the open button. I hope you people have got it. May I click on open?
Yes, ma'am.
Okay, you can click on open. Then within few seconds, this dialog box, that is read Excel file dialog box, will come. It is showing you the worksheet. As we know, in the Excel, there can be so many worksheet possible to enter in a workbook. So in my sheet, I think there is only one sheet available. But if there are more than one sheet available in your workbook, it will show you all the worksheets. So whatever or whichever worksheet you want to open, that you can select and open, right? Then coming to the range. So I don't think we need to give any range because we want to import the complete data here in this SPSS. So I am not giving any of the range. Then you can see this would be the preview of your data. And after that, you can only click on OK. Once you will click on OK, may I click on OK?
Yes, ma'am.
Yeah. Once you will click on OK, the file will be loaded or imported in SPSS like this. I hope you have got the same file like mine.
Yes, ma'am.
Okay, how many of you are performing along with me?
Yes, ma'am.
Okay, only one. Amit sir only. Yes. Okay, so shall I proceed, Amit sir?
Yes, ma'am.
Right. Now, how to perform a reliability? You need to go to the analyze menu. Those who are not performing, they can note down the steps if they want. You can go to the analyze menu, and here you can click on the scale and you can select reliability analysis. So may I click on reliability analysis? Have you found it?
Yes, ma'am. Found it.
Yeah, thank you. Now what you need to do here, all the items, all the questions of your scale are listed at the left hand side of pane. You need to select all the items using the control A button, and you can shift those items in the items box using this arrow key like this. Done.
Okay, ma'am.
Then you can click on the statistics. Here, descriptives for we want to get the descriptives for item, scale, and scale if item deleted. Is it fine? So done.
Repeat, ma'am.
You need to in this particular dialog box, that is the reliability analysis statistics dialog box, you need to see at the left hand side corner descriptives for this section is given. So you need to check all the three check boxes: item, scale, scale if item deleted.
Okay. Okay, ma'am.
That only these
All
are the necessary things which we need to check here, and you can press on the continue button, and then you can see model is already by default alpha, so it will give you the Cronbach's alpha figure. Right now you can click on the OK button. So may I click on OK? I hope. May I?
Okay. Yes, ma'am.
Yeah. Once I clicked on OK, the output viewer of the SPSS is showing me the output. It is showing me total cases, total observations, or total data. Sample size is 121. There is no excluded cases and total item. That is why we are having the total item is also as 121. This is done. May I proceed?
Yes, ma'am.
Coming to the next, reliability statistics. Now this is showing you that your Cronbach's alpha figure is 0.672. So I think you have seen the interpretation part. And if the Cronbach alpha value is less than 0.7, we can call it as a questionable reliability. It is not the reliability which we can work upon, or with this scale we cannot go ahead. Is it clear?
Yes, ma'am.
Right. Now going down, and this is the item statistics, right? Item statistics is showing you the mean, standard deviation, and total observation for the each questions, right? So this is the
Yes, ma'am.
this particular table, and the last table, which is very important one. This table first is the first column of the table is showing you scale mean if item deleted. Means if I will delete question number 1, so the scale mean will come as 96.74. Similarly, if I am deleting the question number 1, scale variance will reach to the 147.242. I think there is some noise. Amit sir, I think it is because of your mic. Yeah, thank you. Now,
Hello, ma'am. Ma'am, there is network issue. I am not from 2-3 minutes. The screen, I am saying it was blank.
so Khan sir, I'm not getting you. What are you saying?
Actually, there will be problem of network. So please repeat from this file when you have this imported data in Excel.
Okay, importing is done, sir.
No, ma'am.
Okay, you need to click on this open data dialog box.
Yes,
Under
ma'am.
this looking, you need to give the location of your file and then files of type. Here you need to set the type as Excel because your file is of Excel file, and then you need to select the file, that is customer satisfaction towards restaurant, and you can click on open. And then
Yes.
as you can see, this is the preview of your data. You can click here, as there is only one worksheet available in your file, so you can go with this particular file and you can click on OK. Once you will click on OK, this will be imported here like this.
Ma'am, before this data, we have to convert it into digits, na? 1, 2, 3, 4, 5, 6. Jubilee.
I think it is already, no?
Hmm.
I
Which
think the
shows
photo I
has
had
been.
given- Sorry. Sorry, I'm
Yes,
not.
ma'am, it is already.
I'm not getting, sir. Who is speaking and what are you saying? Any questions? Any queries?
No, ma'am, continue, please.
Okay, thank you. Fine. So I think after that.
Ma'am, I have one question. Sorry for delay. Just 2 minutes. I wanted to confirm. My name is Kshitij, ma'am.
Yes, sir.
Ma'am, this is the question, and this is the Likert scale answers taken by the.
Scale questions, right?
Okay, so if I see the variable view, it will be numeric only, and the measure will be nominal. Little bit, I'm not able to understand. It should be nominal or.
Sir, usually Likert scale questions are nothing but these are the ordinal scale questions. You can change the type. There is no problem in that.
Okay, so they will not be scale, obviously, no. But Likert is an interval scale, no, ma'am.
As per my opinion, we need to take it as ordinal because we know that intervals are not, because in interval scales work on the equal distance. And if
Understood.
I say agree to disagree or agree to strongly agree, with the distance is not similar.
So some people take as interval scale, some people take as ordinal.
Yes.
It depends
It's
upon us.
up to them, sir. But according to me, it should be interval ordinal. It should not be interval because the gap is not similar. In this
Yes.
strongly agree and agree, we cannot say. Might be possible from
Might be
strong.
possible.
So, for example, you are giving me 4 chocolates. I will turn to the strongly agree. Might be possible, and some may be converted with the help of only few attractions. So that way, that particular thing is not clear.
Little bit of subjectivity is there, yes, ma'am.
Yes, so that is why we can call it as ordinal scale, according to me. But few people are taking it as interval also.
Thank you, ma'am.
Ma'am, so is it dependent on qualitative type of research or quantitative type of research that we are taking into account? Like whether we should go ahead with the ordinal data, nominal data, or the interval data. Ideally, for Likert scale, we usually take this one interval data only. But is it like I'm not sure? Is it like for qualitative purpose? If we are doing some kind of study, we should go ahead with ordinal data as sir is suggesting.
I think Kshitij sir has not suggested anything.
No, ma'am. I have the same confusion what he has. Like what we have seen in the papers is that a Likert scale is taken as scale data, interval scale. But as you said, and I also agree with you that it is little bit subjectivity is there. So what Ravi, I think so, is asking is that does it depend upon the type of research we are undertaking that we will take in the data as, like if we are doing qualitative, but it is
Kshitij sir, may I take upon this?
Yes, ma'am, please.
Yeah, Ravi sir, I think, say for example, I have given you one statement, right? The statement is, my salary is satisfactory. Got my point? And I have given you 5 points: strongly agree, neutral, disagree, strongly disagree, right? Now you are answering this question, or you're answering for this statement that my salary is satisfactory, right? So suppose you are clicking on agree part, right? I have also checked the agree part, but might be possible when my organization is increasing my salary from whatever my salary is. For example, my salary is suppose 50,000, and my organization in the next increment, my organization is increasing my salary from 50 to 60, and suppose your salary is increased from 50 to 55 only. So might be possible you can turn to the strongly agree, and I also turn to the strongly agree. So you can understand this point. That is not fixed. Interval is not fixed there.
Correct.
right? So generally what happens if we are talking about Likert scale questions and if we are performing t-test or z-test, in that case what these tests are doing, they are taking the observations and calculating its mean. So that way we can consider these scales as interval scale in that case.
Okay, ma'am.
Hello. Sorry to interrupt, ma'am. Ma'am, Debabrat this side. Ma'am,
Yes,
as
sir.
you cited that the salary example that you cited, but from the company's point of view, the reference will be fixed. No, then how can it be changed?
It is
I
depending
have a
on the performance, sir, might be possible. But thing is, it is totally talking about the satisfaction level. My satisfaction is means my satisfaction from dissatisfaction to satisfaction. In 5,000, I am maybe Ravi sir is converting, or Ravi sir's satisfaction is converting as a means dissatisfaction is converted into the satisfaction with rupees 5,000 only. But my satisfaction is dissatisfaction is converting into the satisfaction with rupees 10,000. So there is
So-
not equal distance.
So that means the fixation or the non-fixation of the scale will vary from researcher to researcher.
No, sir. I think from question to question. No, why from researcher to researcher? I
Ma'am,
think
I have one point to quote here, if you may permit.
obviously.
Say for example, I want to put agree as my as three rank 3, and some may consider that 3 as not 3 itself. They may have a 5-point or 6-point Likert scale, and that agree again changes, right? See, my whole point is, even I have went through many of the research papers, and the question or this is a very long debatable, I guess, topic, because many have taken that particular stuff as a ordinal scale, and obviously most of them have used it as interval
Interval scale, yes.
scale, right? So I also go with the point that you are suggesting, but this is what many people has actually put in into, and those are published into very good journals,
Yes,
and
yes,
those are not
agree.
cloned paper or something like that, right?
Yes, ma'am. It's
but-
actually highly debatable. It's actually highly debatable one. Like
yes,
Ravi sir
obviously.
quoted, it's highly
Yes,
debatable.
sir, I think one more thing is here. As I said, if we are using t-test on a Likert scale, in that case,
Very
it is
true.
an interval scale question because it is
Ma'am,
taking the
ma'am,
mean
because
value in that case.
I actually faced the same issue during my PhD thesis. My guide and my expert, like external, both had a different opinion, but thankfully I got my PhD awarded. So that's the beautiful
Congratulations.
part. That's the beautiful part. But we were in a confusion with whether we should go ahead with the chi-square test or the t-test, just because whether we are considering the whole data as a qualitative data, quantitative data.
If we are talking about chi-square test, in that case, if you are taking a count, it will convert. This question will convert into the chi-square also. If you are calculating how many of the people are saying strongly agree, how many of the people are saying agree, so it will be converted into the count. In that case, you can go for chi-square also. That is what I am saying. It is varying from person to person. But till for whatever I studied from the persons or from the experts, what I discussed. So this is what my understanding, which I am discussing with you. So totally
Okay, ma'am.
up to the people, the way they want to do it. Yes.
Ma'am, we can move ahead because again,
Obviously.
it's a long topic. Right?
Yes.
Thank you so much, ma'am.
Thank you so much.
Thanks for the time.
Yeah. So I think we were here on the item total statistics, right? So as I said, firstly, this item you are deleting, this will be the total.
Ma'am, you were explaining that we have taken the data. You were just coming back again. Can you just take it like that we have taken the data and then what we have to do further? Even my screen was blank at that time.
Okay.
The data,
After
data
bringing the data in your SPSS, you need to go to the analyze. You need to click on the scale and you need to click on the reliability analysis. Like this, all the items will be hanging here on the left hand side. You need to bring them at the right hand side. You can go to the statistics and you can check first 3 checkboxes and you can press on continue.
1 minute, ma'am. I went to the analyze and I went to the scale. And then I have to go to reliability analysis, right?
Right.
I think I have some different thing. My questions are coming on the left-hand side and I am getting items and ratings.
Same, sir. I said you need to select and bring it to the right-hand side.
Sorry.
Yes. I said this and then you need to click
I'll
on
have to select, send it to items. Okay, I have selected all things to items.
Yeah. Now you need to click on statistics, check first 3 checkboxes and click on continue.
Item, scale, and scale if item deleted. Yes. Okay, ma'am.
Click on continue, then click on OK. That's all. You will get the same outputs the way I'm getting.
Yes, ma'am, I got it. Thank you.
So we were on the last table. You can see this is the scale.
Excuse me, ma'am, can I just interrupt just for a second, ma'am?
Yes, yes.
Actually, my network is a bit poor, so I'm not understanding what is that Q1, Q2, something like that.
Question 1, question 2.
Okay. But what is that question? Question 1, like, is it just an imaginary question or like what is the
You can take it. It is an imaginary question related to the satisfaction.
Okay. Thank you, ma'am.
Okay. Now, because this is a demo only, I need to explain you how to check the reliability, right? So now further I think I was talking about this. Question 1, if you are deleting, this will be your scale mean. Question 1, you are deleting, this will be your scale variance. This is the corrected item total correlation. And last one is the Cronbach's alpha if you are deleting the item 1. So presently, your Cronbach's alpha is 0.672, right? So if you are dropping your question number 1 from the scale, it will bring your Cronbach's alpha to 0.675, right? Now you can see maximum of the Cronbach alpha is reaching to up to what level? 0.678, 0.8689. I think it is, if you are dropping your item number 23, it will maximum reach to the 0.689, right? Means it is no way it is reaching to the 0.7. Now, next way is you need to check the corrected item total correlation figure. As I said, firstly, you need to check for whether for any of the item you are getting the negative item total correlation. So you need to check that. I'm scrolling down. Yes, I think I found there are 2 items, question number 23 and question number 24. For both the items, this item total correlation is negative. I hope you have also diagnosed it, right? Everyone has got it? 2 items?
Yes. Yes.
Yes, ma'am.
Yes. Yes.
Now question number 3 and question number 23 and 24. Now what you need to do, you need to again go to the, I'm using, I think you can see there is a shortcut button available which is showing you few of the previous tools which you have already used in SPSS. So I'm clicking on the reliability analysis here, and from the right box I'm picking question number 23 and question number 24. I think 23 and 24, right? Yes, I'm selecting both the items and shifting back to the left hand side box. Is it fine?
Yes, ma'am.
Now you can click on the OK button and you can see the improvement in the Cronbach's alpha value. You can see output is coming and it is coming this time as 0.701. So now your total items came to the 29 from 31 because we have dropped 2 of the items from the scale. So with the 29 items, we are getting the Cronbach alpha value is 0.701, which is acceptable figure. If you want to improve more, you can again go and check if some of the item total correlation are very poor, very small figures, like this 0.041, 0.041. So 0.032, I think it is the smallest one till now. So that one more is coming 0.009. This is the very small figure. Question number 20. So question number 27. So that would be total your call. If you are satisfied with 0.701, you can go ahead. If you want to drop 1 or 2 more items, that you can take a call and you can drop and you can improve your Cronbach alpha figure. But friends,
can you just explain in words what we did? Like these 2 things, what we did. Can you just explain in words? Exactly. I understood what you did in SPSS, just to understand what we did actually.
I'm speaking, sir.
Like what we did actually, we removed the total.
2 items we have dropped. Previously,
yes,
it was
yes.
it were 31. For
yes,
31 items, we are getting this figure. Now, 2 items we have dropped, so your Cronbach's alpha is coming as 0.70.
Yes, ma'am. The Cronbach's alpha is coming because we have dropped the
2 items.
Items with having
item correlation was negative.
Very low correlation.
Negative. Firstly, negative we have targeted.
Okay. Okay.
Fine, everyone.
One more question, ma'am. Ma'am, supposing if I adopt like questionnaire which has been tested and the Cronbach alpha is more than 0.7 something, so do we still have to go for this reliability analysis?
Sorry, I'm not getting.
Supposing let me take an example of a job satisfaction scale. which
Yes.
is which has been adopted from Spencer or something like that, and this thing has been reliability test has been done, and which is coming to 0.7 or something like that. In that case, if I adopt that questionnaire, am I still going to go for that reliability
Yes.
analysis?
Yes, I think in the very first slide I told you this thing. You are using existing skill or you are developing your own skill. In both the cases, you need to always check the reliability of your skill, because in what context the people have used that skill, in which reason they have developed that skill, in which particular time period they have developed that particular skill, they were affecting those factors were affecting these things, right? Might be possible they are getting that reliability. Maybe you're using the same skill in the your reason or at the different time period. So might be possible that reliability has changed, right? So you need to check always.
Thank you. Thank you, ma'am.
Okay. So shall I proceed with the next thing now?
Yes, ma'am.
Okay. So now we will talk about the normality. Give me a second. I think mistakenly I have clicked on the stop screen sharing. Yes. Now we will talk about the normality. I hope my screen is visible. I shared the slides of normality. Is it visible or not?
Yes, ma'am. Visible.
Yeah, fine. So friends, now we will talk about normality. I think in this FDP, this is the second day only. We need to talk 5 more days. And in out of 5 days, for the 4 days, we are discussing about the parametric test, right? So wherever we are talking about the parametric test, usually we need to check the assumptions of parametric test. And one of the important assumption of the parametric test is your data should be reliable data, right? So you need to check whether your variable which is on continuous scale, you can understand, you need to know this thing. Now generally we are checking for the continuous scale variables, right? So if our variable is continuous, you need to check that the variable is normal or not, whether the variable is normally distributed or not. So we need to check whether the bell-shaped curve which we are putting on the histogram, which is covering the maximum of the bars of histogram or not. This is graphically you can check, right? But some more things are there, like we need to check. I hope many of you are knowing there are certain characteristics or features of normal distribution. Among those features, few of them are, suppose, firstly, the mean should be 0 and standard deviation should be 1 of the normal distribution, right? So usually in practical life, it is very hard to get these figures, but still if your data is showing, that is good. But for Likert data, it is quite difficult to get such kind of figures, right? So there is one more feature of the normal distribution, which is your mean, median, and mode should be equal. So if you are calculating mean, median, and mode, if they are coming very close to each other, that way also somewhere we can say that the data is approximately normally distributed. Further, the skewness should be usually 0. For standard normal distribution, skewness should be 0 and kurtosis should be 3. Kurtosis and skewness we will see in the upcoming slides, right? So if these figures are 0 and 3, in that case also we can conclude that the normality of the data is maintained, right? But if these are not matched, in that case we can say that data is not normally distributed, right? As I said, if we talk about, just a minute, I need to go to the next slide, right? Now looking at this particular slide, you can see I need to shift this here. Yeah. Now you can see in this particular graph, these 3 graphs are showing you. The middle graph is showing you this is nothing but this is the normally distributed data's graph. This is the perfect bell-shaped curve, right? In that case, generally mean, median, and mode both are equal. So this is perfectly normally distributed graph or data. Talking about left and right side of the data, graphs, you can see right side of the graph is showing you this is the positively skewed data. Means when the right tail is greater than to the left tail, when the right tail is more or greater than to the left tail, we can call this data as the positively skewed data. When your left tail is greater than to the right tail, we can call it as the negatively skewed data. Or Other way around, I can say when the mean is less than median and median is less than mode, this is the negatively skewed data. Or when mean is greater than to the median and mode, this is known as the positively skewed data. So looking at the figures of these mean, median, and mode, excuse me, looking at the figures of mean, median, and mode also, we can conclude about the normality of the data, right? So here the descriptive statistics play the important role for understanding the normal distribution of the data. Now, what are the methods which we can use to check the normality? So usually there are two methods, numerical methods and the graphical methods. Under the numerical methods, we can keep skewness and kurtosis indicators, then Kolmogorov, Smirnov test, and the Shapiro-Wilks test. These are the three tests which we can use to check the normality of the data. Graphically, we can use histogram, QQ plot, and the box plot. So in both, that is numerical and graphical, we can keep three methods, and using these methods, we can check the normality of the data. I think histogram we all have seen, we all know. It is very easy to make using the Excel or using any software. We can easily create the histogram. Histogram is nothing but it is the depiction of the frequencies of the particular observation, and we can depict, we can say that the height of those bars is indicating the frequencies, right? And there is no gap in the bars of the histogram. Usually in the bar chart or in the bar diagram, we can see there is a gap between the bars, but in histogram there is no gap, right? So that way, this is known as the histogram. Generally, for the continuous or numeric data, we are using the histogram. Now, there can be various kind of histogram shapes we can got. Few of the shapes I have taken here. Looking at the first graph, which is situated at the left hand side, upper side, you can see this graph is nothing but this is showing you the skewed data, because here you can see if I will put a bell-shaped curve on this graph, so your right tail would be greater than to the left tail. That means your data is positively skewed data. Here you can see when two peaks are coming, means two data points are almost showing the same frequency. That means there are two mode available. So that means this is again, this is not a proper, what I can say, the normal distribution of the data, because in generally normal distribution, we are getting only one peak, right? The most middle graph is showing you this is the perfectly normally distributed data's graph, right? Then here it is quite clear. The left hand side, lower left hand side, you can see the graph is showing this is the positively skewed data, and this graph is showing you there means we are unable to interpret anything from this type of the histogram if we are getting this type of histogram, right? So there can be various types of histograms we can get, usually according to the data we are having. Now, talking about, I think in the SPSS, as we have seen yesterday, probably, I think I have shown you using the descriptives and explore option, we can create the histograms also. So this way you can create your histograms in SPSS. Generally, the left hand side histogram is showing you that there is very less spread in the data, because this is little narrow, the bell-shaped curve is narrow, but here the bell-shaped curve is very little spreaded. That means we can call it this, the spread in the data or the deviation in the data is more in comparison to this particular data. Now, QQ plot, usually the output we are getting in SPSS. So looking at the very first left hand side, upper left hand side, you can see this is the normally distributed data QQ plot. QQ plot is quantile plot, right? So this is showing you when your data is following this fitted line. So that way your data is normally distributed. But if your data is deviating, your data points are deviating from the line, in that case your data is skewed data. So if your data is showing you this type of distribution, or data points are showing you this type of distribution, means they are coming to the right, data points are coming to the right hand side. So this is left skewed data. But when data points are going at the left hand side, this is the rightly skewed data. Similarly, talking about the tails, whether the tails are thick or thin. So when most of the data points are coming at this side, both the sides you can see, most of the data points are coming, and That way you can say your data is thickness of the tails is more. So in that case, this is leptokurtic data and this is platokurtic. I think kurtosis I'm discussing in the next slide. Talking about the box plot, yesterday we have discussed this. So this is the box plot. Middle line is median. Upper line of the box is the third quartile. Lower line of the box is the first quartile. This is the upper whisker. This is the lower whisker. And if the outliers are available, they will be exceeding your whiskers. Maybe they can be at the upper whisker side, maybe they can be at the lower whisker side, or maybe they can present at both the sides, right? So this way you can see whether the outliers are available or not. Now, coming to the next slide, talking about the skewness. Skewness is what? It is the measure of asymmetry on your data. Asymmetry on your data, whether your data is symmetrical or not, you need to check that, right? So if mean, median, and mode all are equal, you can call data is perfectly what I can say normally distributed. That means there is no skewness in the data. Means 50% of your data is falling to this middle line and 50% of the data is falling to this middle line. Left hand side and right hand side, both the data is equally both side data is equally distributed. 50% to your mean right hand side, 50% of the left hand side of your mean. So data is perfectly normally distributed. But if your data is means if your left tail is high, means left tail is high, meaning is skewness value is negative. So that way you can call it as a negatively skewed data. In this case, positively skewed data, your mean your skewness value will be positive value, right? So this is positively skewed data, and the distribution of data is not proper. Might be possible that 50%, 60, 70% data is falling at one either of the tail, and remaining data is falling at the other tail, right? So that way, that data is the skewed data. Talking about the kurtosis. Kurtosis is nothing but this is the study of the tails or the sharpness of your bell-shaped curve. How much is the sharp peak of your curve is having? What is the tail story of your curve that you can study in the kurtosis, right? So if positive figure of your kurtosis value is coming, that means your data is positively kurtotic data. Positively kurtotic data meaning is this is the leptokurtic data, and leptokurtic data means this is the blue curve, right? Mesokurtic means this is the normal curve. Here in this case, generally the kurtosis value is coming as 0. Platykurtic, kurtosis value is coming as 3. Platykurtic data means your skewness value, kurtosis value is coming as negative, and your curve will be very flatter type of curve. That is the platykurtic data, right? So your tails will be very close to your x-axis. So using or looking at the graph, we can somewhere understand the kurtosis and skewness of the data, and that way we can interpret the normality of the data, right? So I think this is the conceptual part of the normality. Now I'll take you to the SPSS, and I expect everyone to open the second sheet, which I think I have already shared with the name bank loan, right? You need to select the bank loan file and you need to open it. I think opening of the file I have already explained you, right? I do not need to explain it again, do I?
Yes, ma'am.
Do I need to explain it again?
No, ma'am. No, ma'am.
Okay. Fine. So I hope you people have brought the file here in SPSS. May I start explaining normality?
Yes, ma'am.
Okay. Now you need to go to the Analyze menu. Click on Descriptive Statistics, and here you need to go to the Explore. You can take a pic. You can write down the steps, whatever you want. Go to the Analyze, Descriptive Statistics, and Explore. May I click on Explore?
Yes, ma'am.
Okay. Now, after clicking on the Explore, there are so many variables available. As I said, generally we are checking the normality of the continuous or numeric variable, right? So there are various numeric variable available. So one of the variable you can check. I think income is most appropriate here to take. I'm taking the income variable and shifting it to the dependent list. I hope everyone has done this. May I go ahead?
Yes,
Yes,
Now you can click on the statistics button. So it is giving you the descriptive statistics at 95% confidence level. You can click on continue, means you do not need to touch anything here. Whatever is the by default setting, we will go with that. Now you can click on the plots button. Here under the box plot, it is giving you factor levels together. Although we haven't circulate, as you can see here under the factor, we haven't passed any factor variable, any categorical variable. We have not shifted here. So there is no meaning. Whatever we want to go with, whether the factor levels together or dependent together, we can go with, because we are not going according to the categorical variable. So whatever is the by default setting, you can go with it. Then under the descriptives, stem and leaf, I think it is very older version of checking the normality. Rather than that, we can select the histogram. And lastly, to get the Shapirovil's test and the Kolmogorov-Smirnov test, you need to click on this normality plots with test. And then we are all set to generate. May I press continue?
yes, ma'am.
Fine. Apart from that, we do not need to do anything, or except you can check display showing both. That means it will give you statistics and plots both. If you want to see only statistics, you can check here. You can check this. You can click on this radio button, or if you want to get only plots, you can click on this plots button. But we want to see both the things. We are going with the both option. This is the by default option, and you can click on OK to get the output. So I hope, may I click on OK?
Yes, ma'am.
Okay. Okay, outputs are here with us. It is generated. Now you can see it is showing you the income. Total observations are 850. There is no missing value available. That is why this n is 0. So the total is as it is. That is 850. Nothing is subtracted, right? Because no missing value is removed, right? Coming to the descriptives. So for income, the mean income is 46.68. 95% confidence interval of mean is 44.08 to 49.27. 5% trimmed mean, when it means when we are removing the outliers, 5% outliers from both the sides. This is the trimmed mean, which is 41.52. You can see there is a very noticeable difference in these two figures. That means it is showing there are outliers available, right? Median is coming as 35. Variance is 1485.567. Standard deviation is 38.543. Minimum income is 13. Maximum is 446. Range is 433. That is the difference of maximum, means maximum minus minimum will give you the range. Interquartile range means third quartile, and the difference means the difference of third and first quartile is 32. Skewness is 3.701. Kurtosis is 22.486. So you can see, as I said yesterday, I think I told this thing, generally skewness is plus minus 2, as in the real world it is very hard to get zero skewness. So we are having the threshold value, that is plus minus 2, and kurtosis should be plus minus 3. But both the figures are very high here. Means whatever are the threshold value, from those threshold value, these figures are very high. That is, we can say, looking at these figures, we can say data is not normally distributed. Other property of normal distribution, mean and median should be equal or approximate similar. So we can find there is a gap, very small, very large gap is existing here, right? So that way again it is difficult to say anything about the normality. Means normality is not, we cannot say that the income is normally distributed here. Is it fine? May I go ahead with the next table?
Yes, ma'am.
Now, test of normality. Here you can see both the tests, that is Kolmogorov-Smirnov and the Shapirovil's, both we are getting in the one table only. Usually when the sample size is sufficiently large, more than 1000 or something, we can go for Kolmogorov. But when the sample size is below 1000, we can report the Shapirovil's test. So as our sample size is around 850, we can go with the Shapirovil's test, right? Is it fine? May I?
Yes, ma'am.
Yeah. So here, firstly, if you are making your notes, you can write the hypothesis here for the normality checking using the Shapirovil's test. You can write the normality of your what is the hypothesis. So may I?
Yes, ma'am.
You can write a variable is normally distributed. This will be the null hypothesis of Shapiro-Wilks test.
Okay, ma'am.
Everyone has noted down, I hope, right? So this would be the hypothesis of Shapiro-Wilks test. Thus, the variable is normally distributed. So looking at the significant value, which is coming as 0.000, right? So I think every one of us is knowing this thing. If we are using a softwares are giving us the p-value or significant value, right? So this p-value you need to compare with your level of significance. So we can say this is less than 0.05, right? I say this thing that p is less than 0.05.
Yes, ma'am.
Yes. So if it is less than 0.05, in that case, we are not going to accept our null hypothesis. So that means we can conclude that the income is not normally distributed. Fine.
Yes, ma'am.
Yes. Going ahead, talking about the histogram, I think histogram is very clearly saying us that your data is skewed data. Your data is positively skewed because these particular bars, you can say they are going smaller when we are going towards to the right hand side. So these are going very smaller, and most of the bars are coming at the right hand side in comparison to the left hand side, because this is your mean value, this is the mode value, which is the highest figure, right? So we can call it as your data is not normally distributed, it is positively skewed because left tail will be higher than to the right tail will be higher in comparison to the left tail. And also looking at the skewness, where is skewness and kurtosis, both are the positive figure. That means your data is positively kurtotic, that is it is the leptokurtic data, and this data is positively skewed data, right? Now you can double click on this histogram area. It will lend you to the chart editor. Here you need to click on the lower bar. In that bar you need to select this particular second last option, which is showing you the distribution curve, right? You can click on this. It is showing you by default normal distribution curve, and you need to only close this, and you can close this particular chart editor also, and you would be able to see that the bell-shaped curve is there on your histogram. So this is
Repeat again, ma'am.
double click on the chart area.
Okay.
Then you need to go to the lower bar, third, I think second bar. Here you can find second last option, the distribution curve. You can click on this. I am not clicking, otherwise it will hide my curve. You can click on this, and it will show you
Okay.
one more window, and you need to nothing you need to do. By default, it is showing you the normal curve. You can close that, and you can close your chart editor also. Done?
Okay. Okay, ma'am.
And we can see the bell-shaped curve is coming here. So which is showing that your right tail is greater than your left tail. We can conclude that data is not normally distributed, right? It is positively skewed data. Now for positively skewed data also, we have seen the QQ plot is also saying the same story. Your most of the data points means it is showing you what I can say, it is showing you convex concave. I don't know what exactly we can call it as. Most of the data points are going at the left hand side. These points are going at the left hand side. That means your data is the positively skewed data, right? The trended normal QQ plot we do not need to report. Come down to the box plot. Sorry. Talking about the box plot, you can see box plot is coming, and there are so many circles and asterisks which are coming beyond your upper whisker, right? I hope you can see. And the highest one. So usually when your outliers are coming as circle, we can call them as a insignificant outliers. Means we can go with that type of outliers, and it will not much impact your data or your mean figures, right? But when these are showing by the asterisk sign, that means these are the significant outliers, and we need to think upon them whether we need to include them or not. That would be the R call, right? Now you need to click on
Well,
double click on
how do we know which are the dots? Like, the circles will be beyond the 1.5 times IQR plus the mean, no? But still they will be outlier, no?
They will be outlier.
But how
if
do we
they
know
are
which
coming-
outlier we have to take and which outlier we cannot
I
take?
think, sir, it is the same discussion which we have held yesterday also. That will be totally your call, because
Okay.
once we are submitting
Okay.
the study, we need to give that justification why we have kept them, right? So here,
Mhm.
usually in SPSS, generally the circles are showing you the insignificant outliers. Asterisks are the significant outliers. Means if you are keeping them, they will definitely impact your results, right?
I understood, ma'am. But what I'm saying is that these circles, you're saying is that if we keep them, it will not affect the results. So
It will
there will be
obviously-
some coding
Sir,
in SPSS which is saying that this is the circle. So how do we?
Sir, I'm saying it will not. I'm not saying they will not. They will impact, but if I'm keeping these asterisks, they will definitely largely impact your results, right?
I
They
understand.
will impact, but that will be again.
What is the
your-
formula for these circles, ma'am? I'm asking that what is the formula for?
Sir,
or what is
formula, it is quite clear. The formula, I think you have already told us. IQR
1.5 times.
1.5 times, right?
So that is the till whisker, no? That is still whisker.
Still
Okay,
whisker. And beyond that, these will be considered as whatever values are coming beyond that value, they will be treated as the outliers,
okay.
right? So that would be totally a researcher's call. Here you can see there are so many outliers are available. So we cannot drop all of them because it will impact the size also, sample size also, right? So you need to take a call how many of them you want to drop here, right? So you can click on any of the asterisk, and then you can click right click on that, and you can click on go to case. Is it clear?
Yes, ma'am.
Once you will click on go to case, your Excel means your data file will come in front of you, and it will highlighting all the outliers. This case number 40, this case number 43, whatever it is, means whatever these are the numbers, IDs, these are the outliers for us, right? So this will be our call whether we want to keep these in our data set or not. Is it fine to everyone?
Yes, ma'am.
Okay, just a minute. Yes, and this will be your last output. Just a minute, I need to close it. We will be on the output. This would be the last output of your explore option in the SPSS, and this way we can check the reliability of the data. So I think this is all from my side for the day. Now the platform is open for question and answer.
Ma'am, can you share PPT?
PPTs are usually I won't share, but I'll give you the content.
Okay, thank you.
Okay. Anything else?
Hello, ma'am, can you hear me?
Yeah, fine. I can.
It's just slightly out of the content, but if you permit, may I go, please? Slide.
Obviously, sir, I
like,
cannot deny
ma'am,
anyone.
ma'am, actually, as this training program is completely focusing on SPSS, like we have different softwares coming nowadays, like you might have heard about R, these all things. So can you basically tell me which one will be better as a researcher, SPSS or R? Like how do they differentiate? Is it just like upgradations of different softwares? We get different high-end multiple tools which we can use, or SPSS is well and enough for a particular researcher to go on with the research?
Very good question, sir. Usually, I start from Excel, right? Excel, I think it is very handy and anyone can easily use it because in day-to-day life, we are using the Excel, but there are certain limitations of Excel. Excel has a limitation of data storage, firstly. If we are dealing with the big data kind of things, Excel cannot do that. That is the first thing. Apart from that, if we want to perform factor analysis, something advanced statistical tool that we cannot do in Excel, right? So moving a step ahead, we are talking about SPSS. SPSS will providing you all these things. Using that, you can do that. Coming to the programming languages like R and Python, that also we can use because they are far better than these statistical tools which we are talking about like Excel and SPSS. But the problem with these tools is if you are not having that forte or that type of mindset of using the programming languages, so in that case usually people are means afraid of using those type of software. That can be one thing, but as I am also teaching R, I usually take workshops on R. I am teaching R in my college also for students. But I think using R, there is no difficulty. It is not like that. You can easily use it. But if you are not much comfortable, you want to only go with, means you want to keep yourself aloof from the programming. In that case, SPSS is okay. But now the era is usually if you are using the tool like R or Python, so they are providing you some other information, and there are various types of libraries available which we cannot do in SPSS, that can we do in those type of softwares also. R is very rich from the point of view of graphical representation. And as for statistical analysis also, there are various libraries available which are making the life or calculations or the analysis easier for us. But again, I'll tell that if we are not having that type of programming background, so usually people are not want to go in that type of software. So that is why, because SPSS is only menu driven type of software, you need to only click and you need to shift your variables, you can get the output. So totally depending upon researchers, what type of software they want to use. But if they are using R and Python, I think that would be okay. That would be good.
I'm supposingly, let's assume that I want to find out Cronbach's alpha. I'm just giving an assumption at a very ground level. Let us assume that for a set of interrelated constructs and variables, I have found out a Cronbach's alpha in SPSS. And that same Cronbach alpha, I'm putting it in R, right? So is it mandate, or is there any hands-on thumbs rule that for a Cronbach alpha, we need to use this particular software? Because I have came across one particular researcher, they have put a question that the Cronbach alpha that you have found out, from which software have you used? So I have said that I had used SPSS. No, then you have to use R, because R is more valid and reliable than SPSS.
Precise results generally usually we are getting from the programming languages. That is what I told you, because many of the good journals generally they are looking which type of softwares we are using. As I said, I think you also said, because these softwares are updated on daily basis. There are so many libraries and functions were uploaded by the community.
Ma'am, but that doesn't indicate no ki if you are using Cronbach alpha, using SPSS to find out Cronbach alpha, the result will be irrelevant, right?
It is not irrelevant, but preciseness will be more in case of R and Python in comparison to the SPSS. So it is, and one more thing, sir, it is totally depending upon the level or quality what the journal or the editors want to maintain for their journals. So maybe possible with that mindset we are posing that thing.
Okay, that means from your explanation, I can inform one thing, ma'am. If it is highly empirical research and carries more of a qualitative aspect, and where literature has been done very few, I think they are searching for R.
Yes.
Okay, okay. Thanks for your insights, ma'am. Thank you.
Thank you so much, sir. Okay. Any other queries? Okay, no queries. So can we end today's session?
Yes, ma'am. I know nothing from my end.
Okay. Okay. So if you want, any of you want to switch on your cameras, I can capture your faces for our day, and then we can wind up the session. Anyone is switching on the camera? Okay, Rajiv sir. Hi, Ravi sir. Hello. क्या बात है? Hi sir.
Ma'am, I have one doubt actually.
Yes.
Ma'am, if we say 2 plus 2 equals to 4.
Yes.
Hello.
Yes, yes, I can hear you.
Ma'am, in statistics, if we say 2 plus 2 equals to 4, right, then there should not be major difference whether we should use SPSS or R or EVS, any software, right? Because the output might result into the same. I don't know whether my question holds relevant or not, but that's the doubt I'm having. If we go by the statistics, see, research is being done not from like the SPSS has emerged into. The researchers has been using all kind of statistics way before SPSS came into picture, right?
Yes.
So how can we justify that putting the data in SPSS will result a less precise output than R?
I think, sir, this is not what we are saying, right? This is said by, this is mischecked by, not said by. Because if these types of things are coming, right? So they are coming with the experience. These things are coming with the comparison only, right? No one will say this thing without checking these things. Might be possible people or the experts of the fields have checked the results, compared the results, and on the basis of that they are saying. And as I said, probably because if suppose I am running an institute, right? So how to maintain the quality of my institute, I will decide, right? So might be possible the journal or the publisher, they are deciding this thing. If we are keeping this type of restrictions, we are keeping this type of things, might be possible that way we are getting, or we are able to refine the quality of the journal. So might be possible that can be the one thing. But usually this happens when we are using because of these SPSS, if I talk about. So SPSS is a software which is made by the IBM, but or maybe SPSS Corporation. Initially was with the SPSS Corporation, now it is with the IBM. But when we talk about programming languages, these are means on daily basis, various types of packages and various types of libraries were developed by the communities. They were uploaded there on the basis of the need analysis, on the basis of these type of observations, right? So that is why reliability is more in those type of software as in comparison to the SPSS. So we cannot raise a question on the editors or maybe on the reviewers. So might be possible with the experiences they are saying this thing to us, because we have not compared those things on a large data set. Maybe they have done those things, maybe they are having that type of experience. That is why they are saying us to do so, right?
Okay.
Okay, so any other question? No. So I think this is all from my side for the day. We will meet tomorrow and we will start with the analysis part of the data from tomorrow onwards, right? Thank you so much for your patience listening to me. Happy learning to all. Goodbye.
Thank you, ma'am.
Yeah,
Thank you,
goodbye.
ma'am. Take care.
Thank you, ma'am. Thank you very
Bye,
much.
Thank you so much.
Thank
Bye.
you, ma'am.
Thank you, ma'am.
Thank you, everyone.
Thank you.
Thank you,
ma'am.
Chanchala ma'am.
Ajay sir, are you here? Thank you so much, Ajay sir. Okay.
Thank you so much for
Thank you, sir.
another wonderful session. Thank you, sir.